assistant professor of philosophy at the University of Oregon, where he teaches courses on the ethics of technology, the Internet Society and philosophy, the philosophy and ethics of AI, data ethics, and critical thinking. His areas of specialty are AI ethics, data ethics, epistemology?
Epistemology.
So close. Of computer simulations and philosophy of computation. In short, he is interested in the philosophical implications of the design, development, and deployment of computational methods and the technologies in science and society. So please welcome Ramón Alvarado.
Thank you.
So I'm very excited to be here. I'm a little bit nervous as well because, I usually give these talks either at conferences or in my lectures, and I wanted to reimagine some of these slides and some of these ideas in a way that weren't just about, something very specific in a paper that I'm writing or something like that. So what I did was just sort of got a lot of the ideas in my papers or in my book and some concerns that I have about artificial intelligence, especially the latest iteration of artificial intelligence, and kind of just threw them all at the slides, right? And so hopefully from there, I'll start with a couple of elementary ideas about what AI is, and we'll move on and see how I understand AI. And then at the end, hopefully we'll have a really good discussion about where we think this technology is going, because of course it's here to stay, right? And where do we want it to be? And hopefully that part is just gonna be me throwing a bunch of little problems, and maybe together we can talk about them, right? So I have two clickers to monitor so that I know what slide is coming next. So let me just give you a map of the talk. First, we're gonna kind of demystify AI, right? There's so many wrong ideas about artificial intelligence, especially when it's related to media and movies and Hollywood and all of those things that make it really exciting, right? So I want to kind of spoil that for you, unfortunately. Then second, once we do that, then I'm gonna talk to you about why I think that AI is kind of special kind of technology. It belongs to a particular category of technology. It is not like others. And then at the end, once we demystify AI and we understand, AI as a specific kind of technology, then we'll delve into some of the epistemic problems, some of the ethical problems, and maybe some of the philosophical problems, right? So let's start with first things first, right? We need to demystify AI. Why is it necessary that we have to demystify it? Well, because we get little notions like this from media, right? Where we have a strange kind of, this is a depiction of the Turing test, in which somebody's chatting with an AI, and of course the AI is supposedly laughing at the person, right? But there's all kinds of weird things happening here. First of all, if this is a connected robot, why does it even need to be typing, right? Or why does it even need a display to be watching? Like, there's all of these weird ideas about what AI, this thing doesn't tell us. It just tells us there's a robotic arm, there's a computer, it's talking to this person, but is that really AI? Well, it's kind of weird, right? Then we get other kind of depictions in media that are a little bit more sort of terrifying, right? So if you've seen Westworld, right, this is a show in which there's like an amusement park that's full of artificial intelligence or artificial beings, right? And people get to do very cruel things to them and stuff like that. I actually haven't watched it because I couldn't, right? It was just a little bit too much for me, especially when you kind of know the technology and you kind of know what it can do, what it does, and all that stuff. It just seems too much like fiction, or like not even science fiction, but it just seems too weird. Anyway, again, is this what AI is, right? It doesn't look like that to me. This is just a robot that has some sort of semblance to a human. And again, that could be done just by gears and pulleys, right? So again, not exactly AI. And then if you just type AI like I did on Google this afternoon, right, you'll get all of these weird things, right? First of all, there's this sort of magical image of brains and circuits and sparks going all over the place, right? And we get just these weird depictions that don't really explain much, and in fact, make things a little bit more confusing. Again, we have this super sophisticated robot that I hope has Wi-Fi in its brain, but it's still using a computer, right, to type or to look stuff up. I don't know what it's doing, right? It's one of those weird things. Here we get a bit more philosophical AI. One is pondering some sort of mathematical, physical, or physics problem, right? Same exact robot is pondering, I don't know, the nature of the city or something like that. And then we have that one over there again, which is really strange to me. All of these ideas, all of these notions of what AI is, specifically when we get it from media, it's laden with maybe 20th century thinking, maybe 19th century thinking, when we're still thinking about robots as the thing that would be artificially intelligent, right? That's not the case today. AI is a little bit more of an infrastructure of data sets and analytic tools, as we will see, right? Not something like this. And so I just want to, again, kind of flag that these kinds of depictions are strange. They don't really tell us much about AI. And one thing that you can start seeing is that there's a strange uniformity. You see this robot is exactly as that robot, and that robot is exactly as that robot over there, which again speaks a little bit about AI because a lot of these images are created by AI. And AI can only just kind of repeat certain things, right? So you tell it, give me a picture of AI contemplating the universe, and it's gonna draw from images that it already knows and things like, and you can start seeing that now AI is kind of populating Google with images generated by AI, right? And so things are starting to become a little bit more uniform. There's this expression that is used in statistics, like the regression to the mean. When you do something enough times, there's gonna be a regularity to it, right? Then in AI, we have this expression of the regression to the meh, which is if you do things several times, they're just gonna start looking exactly the same, boring, standardized kind of images, right? So instead of the regression to the mean, is the regression to the meh, and you can start seeing that the robots start becoming a little bit more boring, right? Anyway, where I was going with this is that we have to clarify what AI is, and my agenda is, of course, to make AI boring again, right? I'm not sure what the acronym would be, maybe, or maybe, you know, something like that. It won't be MABA, but it would be something like that, right? Why? Well, again, because of these depictions that are just too strange. One of the first steps to make AI boring again, or at least demystify it, is to understand that it has meant completely different things throughout the decades. When people said AI is gonna overtake the world in the 1940s, they meant something completely different. When they did it in the 1960s, completely different. In the 90s, again and again and again, right? So here we see a graph in which we have what they're called AI springs and AI winters. The spring is when somebody comes with a really cool idea in artificial intelligence and lots of money is thrown into that, right? Either by the Department of Defense or universities or the National Science Foundation. And so there's a spring, right? Everything is blooming. And then suddenly there's a winter when people realize, oh, that's not gonna work, right? And the funding starts dwindling and stuff like that. So let's talk about the first one just really quickly. The first one was good old-fashioned AI, GoFi. What do we mean by good old-fashioned AI? It was the kind of AI that was intelligent in virtue of telling it exactly what it needed to do when it needed to do it, right? If you were to write an algorithm for AI, that means that every single specific movement had to be there. There were very long specifics going for that, right? And so some of those were just solve this problem by doing this, and then the machine will solve that problem by doing that. Other ones were like, let's play chess. Here are the rules. This is exactly the kinds of movements that you can make. Here is a set of possible ways in which you can move it if there's another piece like that. But again, the computer knew nothing, learned nothing. You had to tell it exactly what to do and when, right? That's good old-fashioned AI. People started realizing, wait, that's too taxing. There's so much stuff that we need to tell every single machine, every single algorithm. It gets too complicated. That's not gonna work. That's not where AI is gonna come from. So then the winter starts. And then in the 1980s, people start saying, it's like, well, you know why computers cannot really sort of tackle some of those more complicated tasks? Is because they don't have enough common knowledge, background knowledge. And what if we started giving it all those knowledge? And so people started coming up with expert systems. You wanted an AI or an algorithm that did what a lawyer did or did what a doctor did. Okay, well, let's give the AI all of this information about the terms that the people use in that industry, right? So if you were, for example, I want to build an AI that calls the shoe store on Wall Street, right? And I just build that AI. Well, first of all, I have to tell the AI, well, what is call? right? What is a call? What other terms are associated with it? Phoning or talking or addressing. Okay, I need to tell it call shoe store. I need to tell it what shoe is, and then feet, and then podiatrist, and all of the terms associated with it. I need to tell it what a store is. What is a store, a shop, and all blah, 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 blah. And then today. What is today in reference to yesterday? All of that stuff, right? So people started building all those expert systems with all of those words and concepts associated. Very soon they found out that that's actually very taxing again, right? And not only that, but especially if you come from where I come from in Juarez, Mexico, if you were 5 years old and your grandma told you, go to the store and bring me a Coke bottle and also buy yourself a candy. I was 5 years old. I could just go, and the store was maybe 3-5 blocks away. I would still turn to the left. I knew where to go. And there's so much knowledge in a 5-year-old, even a 4-year-old, that doesn't need to be explicit, right? It doesn't really need to know what a street is. It just kind of navigates the world in a different sense. So people started realizing, wait, even very simple tasks that kids can do are so complex and so full of concepts, right? So again, trying to do an expert system through this method is not going to work. So money starts going down. It didn't really work, right? Then again, in the 80s, somebody came up with one tiny idea, which is called the perceptron. And the perceptron was just this function where you put an input, it analyzes it, it tells you whether it should be a yes or a no, and then it lights up a bulb or it gives you an output, right? The perceptron was supposed to simulate new neurons in your brain, right? Anyway, it didn't go anywhere because there was not enough computing power, there was not enough data to kind of make it work. So again, it died a little bit with the winter. But in the 2000s, especially nearing 2010, people rediscovered that same idea of the perceptron, and they called them neural networks. And neural networks started doing a lot of really good work in analyzing data. There was enough computing power in the 2000s, but also enough data, because now we were all on the internet, we were posting all kinds of things, we were building gigantic data sets, and because of that, then there was the third boom in which we're still there, right? So people started worrying about AI for social good. Hey, can we use this stuff for really good, cool stuff? People started thinking about autonomous weapons, autonomous vehicles, about deep learning. And then, of course, we saw the success of AlphaGo, which plays Go, a very complicated Asian game that's a bit more complex than chess, with marbles, I think, or little stones. And it actually won. It won the championship, right, to a human. So people were saying, like, oh my God, deep neural networks and machine learning is really gonna be where AI is at. And of course, there was a lot of social excitement, and people started talking about AI a little bit more, at least in academic circles for sure, maybe not so much in the sort of public sphere. But then November 2022 happened, right? And it's in everybody's mind, that thing called ChatGPT. ChatGPT was a very complex sort of infrastructure with deep neural networks that are stacked one over the other one, that can analyze language very well. It can analyze the patterns of words. If you say I, what are the odds that the second word is going to be love? What are the chances that the third word is going to be you? It can do that very quickly, right? I love you. So if you type I, it can predict that maybe, not all the time, but maybe 40% of the time, the second word after I is love. And it can almost tell for sure that 95% of the time after I love follows you, right? So it can do that kind of statistic analysis on pattern of language, and then it can reproduce it, right? And ChatGPT was sort of the interface that you could play with, right? So then now people like us that are not computer scientists, that are not engineers, could just go online and start talking to this machine that can kind of produce text, that can kind of emulate what we do when we converse with one another. That's why it's called ChatGPT, right? And so that's where we're at right now. Everybody's talking about AI because of ChatGPT, because of the language models that it has, and because of the language abilities that it has, right? But again, I want to go back, and we're still not, demystifying AI yet. I want to demystify it so that then we can understand what it is that ChatGPT does, what it is that these other AI systems do, and then we can accordingly worry, right? So what exactly is AI? One of my favorite places to go when I have to explain what AI really is something from 1969, and is by Herbert Simon. Herbert Simon wrote a book in 1969 called The Sciences of the Artificial. That was the book that established the science schools in universities, right? Before that, of course, there was engineering, of course, there was art. There were no industrial design schools. He kind of started it with that book. But anyway, this is a tiny little footnote on like page 4. It's not even part of the text. It's like a little footnote underneath where it says, look, my friends at MIT came up with this term called artificial intelligence. We at Carnegie Mellon and Rand Corporation, we don't use artificial intelligence. It's too messy, right? It's a kind of a weird word. However, right? We use another word, complex information processing systems. That's what we use, right? And he's kind of saying these are the exact same things. It's just that at MIT they call it AI. Over here, we call it complex information processing systems, right? And of course, he's a little bit defeatist here because he says, look, at any rate, 1969, artificial intelligence seems to be here to stay. We're going to be using this term for a long time, so we might as well kind of cope with it, right? And I like to use this footnote precisely because, again, it tells us if we weren't using the term AI, which is really kind of muddy, right? Because it talks about intelligence, which is something we associate closely to humans, etc. What if we use complex information processing systems instead, right? So what is AI? Well, it's complex information processing systems. And remember I told you I was going to make AI boring, right? This is kind of it, right? Because if you look at it, this actually solves all kinds of problems. When we were thinking about whether AI is conscious, well, if you say, is complex information processing conscious? It doesn't make sense, right? If you say, can AI love, right? It kind of sounds like a good question, but if you say, can complex information processing systems love? It doesn't sound like that, right? Because it just doesn't have the same kind of connotation. And so that's why I like to use that particular footnote, right? It tells me exactly what the people that were making this stuff thought it was, how it worked, without getting into sort of problematic nomenclature. And of course, the problem is that we would have solved all kinds of philosophical problems, but then we would have missed out on all kinds of sci-fi, right? A really cool sci-fi, which, sometimes I can watch, sometimes I can't. But of course, you may think that, of course, you're talking about this really old book where somebody's talking about they're all kind of, AI. This is Gray Walters with their cybernetic turtle or cybernetic tortoise, right? And you think it's like, yeah, of course, then complex information processing systems worked. That's what they were. But not today, right? AI is really AI today compared to something like a robotic turtle or something like that, right? You can see here playing. My wife thought this wasn't clear enough as to what the hell this was or what this was, right? And so I decided to just put it in there a little bit bigger. It's just a mechanism that solves paths. It solves problems by telling it go from A to B, and then you put obstacles, and it kind of solves the best way to get to B, right? Again, it was thought to be intelligent, or at least the beginnings of intelligence. And you might be saying, like, yeah, again, if you go with Herbert Simon and think that these complex information systems, this very simple AI, is what AI is, of course you're going to think that they are not that close to us, right? That they're not really artificial intelligence. But what about our AI? Isn't it any different? There must be something more to it, right? Well, here's sort of the answer. The answer is, yeah, there's something different with modern AI, but not that much, right? If you start thinking about what AI used to do, complex information processing, right? Computing mathematical problems, solutions to equations, you give an input, it does some sort of Bayesian calculation to give you the odds of something, and then it gives you an output. Again, that's actually what AI keeps on doing. If you look at this sort of 2017 tweet, I like it because it's just so funny, right? It says, look, if you're trying to get some money from your venture capitalist, call it AI, right? Because that's the thing is gonna sell. But if you're hiring, you want serious engineers, So call it machine learning, right? But you know that as an engineer, if you're doing machine learning, all you're really doing is statistics on data sets, mainly linear regressions, right? And at the end, of course, you're just kind of pressing the button, run, and then debugging if there's a fault, run, debugging, right? And I just really like this because, again, it tells you that AI, especially contemporary AI, especially machine learning AI, the one that we have right now in the third boom, it's just a lot of statistics, right? It's automated, mechanized, if you want, or digitized statistical methods with very powerful computers, right? Regression looks something like this. You can have data sets over here. You run a line just to try to understand the patterns. How far are these dots from the line that's more likely in the middle of the dots, right? You want to know which dots are closer, which ones are further, and then you can start classifying each one of those dots. So, of course, you know, regressions can be quite complicated, right? I don't want to give you a statistics course. I don't even know enough statistics to give you one, but they can get really complicated. So you can think about this as, let's say, words in a love letter, right? And each one of these points are words in a love letter. And so the AI, the machine learning, is trying to see what is the line that tells me, you know, something about these words. Which ones are the lower cadence? Which ones are the higher content of emotional, you know, content and stuff like that? And then it starts just kind of analyzing it, right? This could be, let's say, this could be you. This could be love. This could be I, right? And it just starts analyzing all of those words. Which ones are closer to one another? So maybe here you have I love you. They always come together. Over here, writing a love letter, stuff like that. Anyway, things can get really complicated really quickly, right? This analysis can get more complex. Now you have a three-dimensional kind of grid, right? Where you have not just a linear regression, but all kinds of analysis going on there. Of course, it can get even more complicated. It does get even more complicated than that, especially with, let's say, the last 5 years of AI. That kind of linear regression that I was talking about, that one becomes all of these things, right? And of course, now it's just like really, really complex kinds of analysis. So what am I trying to say with this? The way in which we demystify AI is by understanding that ultimately AI is a multidimensional spreadsheet. So if you have a spreadsheet, right, that analyzes graph, or that where you can build a graph with, imagine just multiple dimensions instead of just rows and columns. And of course, it's on steroids, right? In short, AI is an analysis tool. That's what it is in the 21st century. Maybe it wasn't in the 20th century, but now that's how it has evolved. So now, that doesn't mean that it's not a very powerful tool, right? It is, in fact, an extremely powerful tool. If you're using extractive AI, it means that you can parse, categorize, sort, or classify data points, right? It can analyze patterns for any of those, right? It can analyze trajectories. Where is this trend going? It can analyze clusters, right? And again, if you have a hard time just envisioning this abstract thing, think about how Amazon uses it, right? So for Amazon, these are patterns that say, oh, okay, Sophia bought 3 rain pants in the past 3 months. Chances are that they are in search of rain boots as well. Why don't we predict that and then send them ads for boots since they already bought rain pants and stuff like that? Why? Well, because it's analyzing patterns. It's analyzing your trajectory, meaning, oh, you're going the shopping way, right? So you already bought pants or rain pants, but you don't seem to have boots. You're probably going towards boots, right? It analyzes clusters. Okay, rain gear is a cluster, right? So it understands that. And then the trends, right? And then it can do that with one data set or several ones. Okay, now, you know, here we have an example of a deep neural net. You give it a couple of inputs, orange, round, mirror-like, this kind of front end, this kind of wheel, and then it analyzes it and tells you, actually, yeah, this is 95% likely that this image contains a car, right? Things like that. Now, that's extractive AI, right? It extracts patterns. But then you also have generative AI, which is the one that we're worried about more today because it generates images, it generates text and all that stuff, right? How does it do it? Well, first of all, it has a huge, gigantic data set of things like facial features. That's a nose right there, that might be a mouth right there, that's a set of eyes right there. And then it has a function that tells that, for any given image, the nose is super important, maybe the skin color not so much. Oh, but this little feature, I don't know, this one right here is gonna be super important. So all the dark ones will be features that the machine should take as very important, and then it reproduces the image. Right? It can just generate it. Why? Well, because it has some data, right? And it has seen the patterns, it analyzed the clusters and all that stuff. So now you can see this is the actual picture, this is a generated picture, an approximation. And it only does it because, again, it has all these facial features, and then you give it a function saying, eyes should probably be closer, eyes are usually darker, eyes are usually very important to faces, right? Nose are important to faces, maybe cheeks are not that important, mouth is important to faces, maybe hair is not as important to faces. And so it does all the math required for that, and then it reproduces something like that, right? This is just from one data set, one picture that it analyzed. Of course, when you have thousands and millions, actually in the latest data sets, there are billions of images from the internet, right? It can reproduce all kinds of faces and things like that. Okay, so again, very powerful tool. And it works because of data sets that we have. So here in the United States, we create these really strange data sets. This is an MIT data set for indoor scenes. So is this a living room? Is this a kitchen? Is this a playing room? They have all kinds of pictures in there. They label them, and then they train an algorithm to recognize images, such that if you take a picture of this room, give it to the machine and ask, what kind of room is this? It's going to go through all of its training. It's going to say, oh, this is maybe a conference room or something like that, right? We actually have funnier ones, which are like the Stanford dog data set. So this is, Stanford has this gigantic repository of dog pictures, just pure dog pictures. This is one of the more, one of the highest esteemed universities in the world, right? And they furnish this kind of data to other countries and to other industries, right? You can go and use it to train your model or to benchmark your model and stuff like that. And that's how you can get stuff like this, right? Because it has so much data. Anyway, okay. So where am I going with this? Is that we have already kind of demystified what AI is. It's an analytic tool. It does all kinds of weird things thanks to these data sets, and it's just like a spreadsheet on steroids, right? Now with generative AI, things get a little bit tricky. We'll come back to that. But for now, let's just move on to the second point of the talk, right? You might still want to ask, hey, what about robots? I've seen that in the news there's an AI nurse that is helping elderly people. Or, hey, I've seen in the news that AI is taking over our cities with their cars. Or I've also seen that social media is going to be super bad with AI because AI will produce a misinformation deluge. Again, now that we understand what AI is, we can see that any of those things are not exactly AI. They're just applications of AI. So you want to build a robot that's really good at grasping things? Well, I build the mechanism first, and then maybe I can use AI to train its fingers, right? Most fingers, when they grasp things, they're going to do something like this. You're going to put this amount of pressure, blah, blah, blah. So you use the analytic tool to train your robot. That doesn't mean that your robot is AI. It's that you're just using AI to train your robot. Exactly the same thing with autonomous vehicles. Autonomous vehicles are not AI. They just use AI to drive, to be able to compute and analyze streets and problems like that. Okay, so let me see. I should probably start going faster here. What I want to say here is that AI belongs to a specific category that is usually not acknowledged. If you look at this thing, so AI is usually compared, even in the literature, to robots, to other machines, to other technologies, to things like cars, right? And then people say, we should trust AI the way we trust a car. We should trust AI the way we trusted a bulldozer, stuff like that. And I want to say, well, again, we're kind of confusing what AI is with its applications. AI is a specific kind of tool. It's a tool for knowledge. So here's the thing. I want to say there's a very hard distinction between things like this and things like that. You might not buy it, right? You might say like, yeah, no, I'm not sure. But I want to say these kinds of tools do completely different things than these kinds of tools. And I want to say these kinds of tools are tools for knowledge. These are not. This is a tool that is good for digging, for destroying, for plowing through things, for carrying things, for lifting things, physical activities, right? These tools are for computing, calculating, thinking, inferring, right? Intellectual or cognitive kind of abilities, right? So we have technologies, some that help us as humans to carry things. But then we have other technologies that help us to know things. And I want to say that AI is a little bit closer to this than it is to this. So let me just tell you why this category is important, right? So first of all, most people define a tool for knowledge just because you use it for it, right? So imagine I'm trying to solve a problem, I need some knowledge, but I cannot get it. If I use that chair to help me out, solve the problem, and acquire some knowledge, then most people say, oh, guess what? That's a knowledge tool, right? Or you can use your pencil, right? Your pencil, if you use it to solve an equation, you can say, hey, this is a knowledge tool. It helps me know, right? Now, the problem is if you define things in virtue of use, then it's gonna be too broad of a category, right? Because then, guess what? Shelves qualify. If I have a shelf on a laboratory, let's say my chemistry lab, is that a tool of knowledge? It seems like no, right? I mean, it's helping me know. Without the shelf, I couldn't put all my instruments. Without the shelves, maybe I wouldn't have a laboratory. But it doesn't seem to be doing the same kind of thing as a calculator, right? A calculator does something very different. And so again, I don't want to trivialize the concept. I want to say tools of knowledge cannot be so broad that everything qualifies. Right? Here's another way of thinking about it. So some people want to say, hey, what if we just say, if the tool tries to help you cognitively or with perception, like your glasses, right? Or with inferences to do math, for example, or things like that, then it's a tool for knowledge. Why? Well, because you're using it for knowledge, one. Two, also because of the capacities that it's targeting, right? You have the bulldozer that targets physical capacities, and then you have a calculator that targets inferential capacities or cognitive capacities. Now, the problem with this one is that it's also too broad, because then coffee qualifies, right? It turns out that coffee helps me cognitively. It helps me even see better or drive better, right? And even helps me try to make more inference because I'm faster, right? But again, coffee doesn't seem to be doing what a calculator is doing or what AI does, right? It just does something completely different. So then maybe we need a different definition. And here's what I think it's at play. So when I say AI is an epistemic tool, does anybody know what epistemic means or what epistemology is? So epistemology is the study of knowledge. Something that is epistemic is related to knowledge. That's it, right? So whenever I say epistemic, it means that it's related to the study of knowledge, and this is related to the study of knowledge. And so I want to say AI is an epistemic tool. But again, I don't want to just say that it's because it's related to my neurons or the way I think. I want to think a little bit broader. For example, my neurons help me with knowledge, but not in the same way that a textbook does, right? Epistemic is a little bit broader. It captures the textbook. That's an epistemic tool. That's a tool for knowledge. Okay, so now maybe what we can say is that, look, a tool for knowledge is one that is used in a context where you can gain knowledge, like scientific inquiry, or that it plays with knowledge content, like words, like concepts and things like that, instead of dirt, like the bulldozer, right? And it deals with that content by doing some sort of operations like inferences or like mathematics or like adding or like subtracting. Those seem to be different kinds of tasks than just pushing dirt from one place to another. So anyway, why am I saying this, right? Well, because I think AI qualifies as this, right? AI is used in epistemic context. What that means is that it's used for inquiry. We ask it a question. That means we want to know something, so we're using it for knowledge. Sometimes we use it in the lab for scientific purposes, so that means we're using it again for something related to knowledge. It works with words, it works with concepts, with numbers, things that have to do with knowledge, so then it's dealing with content that is epistemic. And of course, it does that like a calculator with operations that are more intellectual. They're not just pushing things, right? They're not just lifting things. They're kind of doing mathematical operations and all that stuff. Okay, so I'll try to go even faster now. So one of the things that you can say is that, yeah, AI qualifies, right? It looks exactly like that's what AI is, given what we used it. It's used in entertainment. You might still say, yeah, Ramon, but AI seems to be used in all kinds of things, right? Entertainment, art, or even just to drive. But like we said earlier, this is just a confusion of where AI is or what AI is particularly, and not exactly its applications. Okay, so now that we know all these things, then we can worry appropriately, right? We know that AI is an analytics tool. We know that analytics tools are a specific kind of tool. They're not like your bulldozer, they're not like your car, they're not like your chair. They target something else, right? So now we can start worrying accordingly, and we can start seeing what are the social, ethical, and philosophical problems these kinds of technology can bring about. And here's where we get to that point in the talk where I told you, I'm just gonna throw a bunch of examples, and then we can start just conversing about them and see what you think about them, right? So here's a quick example of what AI can do. As a generative tool, as a tool of knowledge, and I wonder if you can see it. So I want to ask you a question. The question is, do you know what's wrong with this picture? And you can raise your hand if you have any ideas. Yes, please.
I've never seen Native Americans smiling like that as a group.
That's a great observation, right? What else? Anybody else? Gave it away. Right? That's exactly the thing. So, what about this one?
They're taking a selfie.
Yeah. So now there's no mystery here. This is AI generated. These images are AI generated by Midjourney, which is one of those softwares that a lot of people use. The prompt was, give me a picture of, let's say, Native American warriors taking a selfie. Or give me a picture of Polynesian warriors taking a selfie. And they have several. Give me a picture of samurais taking a selfie, right? All of these historical warriors from different regions of the world were prompted. And this is the kind of thing that it came up. But you kind of identified, you see there's something really weird, right? It doesn't look at all like this. Even if this was prompted, of course, because there were sort of North American or especially European people taking the picture and telling them maybe not to smile or something like that. But it seems a little bit more serious and what a warrior of the times of a tribe would look like when they're trying to appear like a warrior, right? Not like this, right? You can see the difference in expression, right? You can see the difference in expression over here. You can see how emotive this side is. This is a real picture. This is an AI-generated picture. So what's the problem here? Well, the problem is in this essay called AI and the American Smile. Why is it the American Smile? What do you think? Correct, but why is it American? Why is the author calling it American Smile? Well, it turns out that if we go back to those databases, remember I told you the Stanford database for dogs? And then I told you about the MIT database for, well, these images are created with Midjourney. Midjourney goes to a database called Lion, or actually a subset of Lion. Lion is a data set of all the images it could get in the internet. Of all, like we're talking about 7 billion, 5 to 7 billion images. Midjourney is only trained with 2 billion of those so that they clean them up from, like unwanted images and stuff like that. But still 2 billion pictures from the internet, right? So now what happens with that data set? Where did that data set start?
People who have a lot of internet.
People that have a lot of internet. Who were those?
Americans.
Americans, right? So we in the United States started the internet, then France picked it up, and then Germany, right? And these countries were the ones that started uploading pictures a lot faster. And so a vast number of the images on the internet are from Western North American countries, right? Specifically the United States. So this author actually talks about this idea. What is this idea? Well, it's this idea of algorithmic monoculture, where, remember I told you about the regression to the meh, where things started to get standardized and looking exactly the same? Well, this is exactly what this is doing, right? You talk about a Polynesian warrior or something like that, and it looks not like from there. It looks like from here, right? Because again, it's standardizing the kinds of images. Now, when it comes to hiring, it does the same thing. So it's gonna hire only the same kind of people, and it's gonna exclude from jobs the same kind of people. Right? So why? Because it just goes through the data that it already has, and it creates this monoculture. Like when we do with agriculture, we just start kind of sowing the same kind of seed, so we're gonna get the same kind of product, right? And of lesser quality each year, of course. Okay, so that's just one example of pretty easy to see that there's something happening with AI that is a little bit deeper that now we can worry about, right? Instead of thinking that, Arnold is gonna come after us with a machine gun, we can start worrying about things like algorithmic monoculture, because now we understand what AI really is and where it gets its information from, right? But there are deeper issues, and these are the ones that I would just want to talk about really quickly, right? About replacement of human creativity. And so 3 problems really quick. One is our worries with technology. The second one is our notion of intelligence with AI. And the third one, just human creativity. So again, I'm gonna try to go super fast so that we have time to talk. And what I wanna say here is that we've been worrying about technology for a long time. I don't expect you to read this. This is just an excerpt of Plato. Plato, 2,400 years ago, was pondering whether writing was dangerous for thinking, right? So not a lot of people used to write at the time. They used to have conversations. And this is Socrates talking about an Egyptian god that comes and shows another god, hey, guess what I invented? I just invented letters. It's gonna change Egyptian culture. It's gonna be amazing. Now we're gonna have better memory, better knowledge, right? And the other god is like, nah, you don't understand. What you just created is a artifact for oblivion. We're gonna start forgetting. We won't be able to think, right? So think about this. This is writing we're talking about. That's the technology they're discussing. And this is 2,500 years ago, referring to a story that was probably 1,000 years older, right? So we've been worrying about technologies for a long time. More recently, of course, writing 2,000 years ago, and again now, right? The press. So Kierkegaard in the 1700s was really worried about the newspapers. He thought it's like this new invention is gonna destroy meaningfulness, and it's gonna destroy our lives, because now we can just walk around the corner and find all this information without even looking for it. Not only that, we're gonna see the front page where something that happened in India is almost exactly the same size as something that happened around the corner from your house. And you won't know which one is more important than the other. So he was really worried about newspapers. I think we kind of survived newspapers, but I'm not sure. The internet, 30 years ago, Dreyfus was worried there's no way we're ever gonna have online education. It's impossible, it's gonna destroy kids' brains, all that stuff. Well, it seems that we survived it. And of course, search engines like when Yahoo and AOL and then Google came around, people were starting to worry about, wait, what is this gonna do to our kids when they're learning and trying to understand things instead of going to the Britannica Encyclopedia, right? I still have a copy of that from 1984. Yeah, what is it gonna do? So again, I just want to kind of flag that we've been worrying about all of these things without really, without really coming to a conclusion, right? And so when people ask me, why do you think about AI now? What do you think about large language models? What is it gonna do to our kids? I think we're barely starting to kind of understand, right? But one of the things that we need to understand is that it's gonna stay here for a while. I mean, look at writing, right? It's been here for a while. We've survived it, we just lived with it. We use it sometimes, sometimes it's very it destroys a lot of things. Language can destroy a lot of things. Written things can destroy a lot of things. But a lot of times it can edify, right? I mean, look at this building, right? It's built with words. It's built with writing. And most of our civilization is as well, right? So, maybe we should sort of put our worries with AI a little bit in context, right, of all the other technologies that we've been worrying about. Okay, so what about intelligence? Well, we've been working with a weird notion when we say AI, artificial intelligence. We have to think about the early computers. These are the early computers. They were called computers. There were women just going through mathematical problems. One would do the addition, the other one would pass it to the division, then the other one subtracting, and together they can solve an equation. But what's interesting about this is that sometimes these people didn't have to know any math, period, not even a very basic math, because they would receive instructions. If you get a number 3, make sure you turn it into number 5, then divide it by 2. You can divide, yes, okay. If you cannot, then go over here and you just do addition, right? And so a lot of these people didn't really know how to do math. The idea here is not that they were dumb, but that the process was dumbing down what math was about, right? Because it was a system to chunkify very complex calculations to have them really quick for war, right? For sending a missile, for locating an aircraft and stuff like that. So again, when Turing saw this and built or thought about a computer, a machine that could calculate, he was thinking about something like that. And this is weird for me because this is not a very intelligent process. Again, you don't even need math to do it, right? Not even essential math. And so we have a strange kind of notion of intelligence. Now the second one is, okay, now extrapolate this. This is what people thought solving math was. And then they built a machine that solved math like this, and then they thought, oh God, the machine is intelligent. Even though the process was not requiring any intelligence, right? Now think about nowadays, and the reason why I'm thinking about this is because I hear all these people saying, it's the end of human creativity, it's the end of human ingenuity. And then they show me why. And what they show me is a clerical assistant, right? You go to your Alexa, to your Siri, you go to the large language model that can do all kinds of searches for you or write a little sentence for you. Again, it doesn't seem not to diminish that kind of task. It's a very complex task, but it's definitely not the pinnacle of human creativity. Right? When I solve clerical tasks, I'm actually in a different kind of mode. I'm just like, okay, I need to answer this email. I need to check that box. I need to move it, send it to the next person. And it's very robotic. It's not exactly very intelligent or very creative, right? And again, so when people are telling me that this is the time where we should be worried about human intelligence, I'm worried, but why? Why are we even worried about that when what you're showing me is just a very, very sophisticated clerk, right? That can do very, very sophisticated assistant stuff. Okay, now what about the last one? Again, I told you I was just gonna talk very quickly about this. The last one is, well, creativity, right? Is it really gonna be a threat to our creativity if you think about things like the camera and portraits? Right? The camera came around, you can take a better picture of somebody, you can actually do it faster. It didn't end portraiture. We still kind of have people that love doing it and do it very beautifully, right? Presidents still get their portraits done, not by a camera, but by a human being. So again, I want to put this AI, generative AI in context with other technologies, and so we can think about it a little bit more. And then just a last little thought here, of what AI can do, right? Maybe it's really good for illustration, but that doesn't mean that it does art. Now, a lot of people that live off of illustration, of course, are gonna lose their jobs, but artists won't, right? If they still wanna do their art, art will survive because humans like art and they like human art, not just illustrations done by a machine. So, where do we want AI? Maybe for paperwork, maybe for things like writing reports that are boring, maybe for checking boxes, maybe for calling the doctor to make an appointment, things like that, right? And at the end, of course, I want to just think about this. Imagine that I build a machine to do exercise for me. Is it really doing exercise? Am I really doing exercise? Well, no, right? Now imagine that I build a robot that prays for me, right? So instead of me doing the praying, I have, is it really praying? Am I really praying? It doesn't seem like it, right? It seems like some tasks, when you automate them and put them into a machine, destroy the task itself. So the moment I build a praying robot, there's no praying happening. The moment I do an exercise machine, there's no exercise happening, right? Maybe, what if I tell my AI to write my diary every day? Well, maybe there's something about it, but again, isn't the whole point of writing a diary to express yourself and to kind of come to terms with you? And so again, the last question I want to ask is, look, maybe we want him for a writing assistant, but the problem is writing just like exercise, such that when we do it, we're actually doing something to ourselves internally, and you shouldn't or couldn't even just offload it to a machine, right? So that's it. Thank you for listening to this very disparate kind of conversation. If you have any questions, yeah, thanks.